the different ways of summarizing and creating graphs, or the different tabulation methods, and the most common set of graphs that we give, but that we get into to interpret the data. And all of you must agree to this fact that whenever we depict a graph, the purpose is to draw some kind of interpretations from that graph. So with assuming some kind of a data is there with us, what are the different steps we would be doing to do these two activities? So the first part, I would be focusing on what are the different methods to summarize the data, and what are the different common graphs that are available for us. Alright. Now, the first thing we need to understand about any data is every data has 5 characteristics. For every data, I can classify the characteristics into these 5. One is the centeredness. There should be some measure which talks about the centered value of the data. Where is the value centered? What is the middle value in the data? There are various mechanisms to find out the centeredness, right? If I have to describe any data, I have to make sure that these 5 things I am comfortable with. The centeredness of it, there are many tools which we will be looking at in our later sessions. Generally, people use words like mean, median, mode, etc. But those are the different mechanisms which talk about the centeredness. So any data that comes to us, we should be able to measure the centeredness of that data. What is that central value? Along with that, we should also look at the variation in the data. Variation is dispersion. So to what extent the values are dispersing? Are they all concentrated at around a certain value, or are they completely dispersed? What is the pattern of the data as far as the dispersion is concerned? Are they completely spread off, or are they concentrated at a particular location? That is measured by variation. Again, there are different tools to measure variation. The most common one being the standard deviation. We'll come to those calculations and all at a slightly later point, but we need to have a basic understanding on any data that is given to us. Apart from understanding the context of it, or apart from understanding the sampling mechanism, etc., any data that we come across, we should be able to find out the centeredness of it, then the variation in it, then the distribution. If I try to plot the graph of all the possible values along with their frequencies, what is the kind of a shape that that graph is giving? The graph or the chart, what is the shape that it is giving? Is it a bell shape? Is it more of a straight line kind of a graph? Or is it like more skewed towards the right or the left? We'll be seeing some kind of patterns as we move along. So the third characteristic I need to look at in any data is the distribution of the data. And then the fourth one is identify the outliers in the data, which says, is there any value or a set of values which are widely deviating from the most of the other values? If most of the values are around a particular region, but this one specific value is either too high or too low compared to that particular set of other values, then we say these values which are widely away from the most of the other lot are called as outliers. We'll have different mechanisms again to identify the outliers, but this is a simple introductory thing which talks about what are the things we need to look at whenever we talk about analysis of the data. So I need to identify the outliers in the data. and I need to know whether this data is changing over a period of time or is it collected at one particular point in time. Because whatever the characteristics we have collected, whether it is a center or variation or outliers, over a period of time all these characteristics can keep changing. So I need to have at what point in time this data is collected or for what period this particular data is collected. So any time we have to do an analysis on the data, the first thing we would be focusing on is this 5-dimensional characteristics associated with this data. Right? Well, as we move along, we should be doing different mechanisms to compute or calculate these kind of aspects, which will help us in doing a proper data analysis in future. Now, the first step in summarizing the data is to build a frequency distribution. It's a simple table. The frequency distribution table is a simple table as is being shown here. Some of the things is the whole data is partitioned. The entire data is partitioned among several categories. Here you see some kind of categories are created. 60 to 69. There are 12 people. Pulse rates. A sample has been taken and based on that sample, this kind of tabulation if it is done. Okay, people with pulse rates lying between 60 to 69, there are 12 of them. 70 to 79, there are 14 of them, and so on. So, if I can create a table of this form, which talks about some kind of categorization of the entire data into different categories. In this case, we have 7 categories. Right? 1, 2, 3, 4, 5, 6, 7. There are 7 categories into which the entire data has been classified, and corresponding to each category, the total number of data values lying in that particular category is counted. This particular count is what we call as frequency. This entire counting is called as frequency. And definitions wise, if I have categorized this group into 60 and 60 to 69, then 60 is called as the lower limit of the class and 69 is called as the upper limit. There is a difference between the words limit and boundary. We have to be slightly comfortable with the usage of these two words. Limit and boundary. 60 to 69, 60 is the lower limit, which could be the minimum most value that can belong to that class. 69, the maximum most value that can belong to that class. Right? But when we observe this, okay, for the next class, the lower limit is 70, the upper limit is 79. Now, what we are seeing is there is a gap between the upper limit of the previous class and the lower limit of the current class, because the upper limit is 69, the lower limit is 70 for the next class. Now, if at all I have a pulse rate of 69.5, where should I put? In this case, probably that kind of scenario does not exist. So, for that reason, this kind of intervals might have got created. But if I have to talk about the class boundary, it will include even the gap also. The gaps are also uniformly distributed between both the classes. Because the gap is 1 unit, both of them will share half of it. So, the upper boundary will become 69.5 for the first class and the lower boundary will become 69.5 for the next class. Instead of 70, limit can still be 70, but the boundary is 69.5. So, when I have to represent the class boundaries, I will always represent them as 69.5 to 79.5, 79.5 to 89.5 and so on. That is what will constitute my class boundary. I should not leave any kind of a gap which are there as a part of the class limits. In some cases, if my limit itself does not contain any gaps, then my limit, there is no difference between a limit and a boundary. But in case of limits, if there are some kind of gaps between the upper limit of the first class and the lower limit of the next class, then obviously there is a difference between the limits and the boundaries as highlighted here. Then every class we also have a midpoint, which is nothing but just take the average of the limits, not the boundaries. Just take the average of the limits. So 60 plus 69 by 2 makes the midpoint of this class as 64.5. The next one 74.5 and so on. This calculation of the midpoints will help us at a later point for doing some kind of calculations relating to the mean and all, which we'll discuss slightly later. But at this point, for every class, we should also require the midpoints of the class, which are a simple average of the limits. Then when I talk about the class width, what is the size of the